Right in the heart of the City of London, a new landmark is taking shape at 122 Leadenhall Street. Designed by Roger Sturck Harbour and Partners, it's an architectural icon of steel and glass with a distinctive megaframe every 7 floors. The Langer team have thoroughly examined the construction methodology of the building and have identified several areas where key opportunities exist for an active engineered approach to the erection of the asymmetric steel superstructure. After site possession, and to advance the construction of the basement, a 150-ton mobile crane will be lowered down from Leadenhall Street during off-peak hours. Using the same 500-ton mobile crane, a Commodore 630 tower crane will be erected on the basement level 3. This, in turn, will then be used to dismantle the existing tower crane in the northern section of the site. The existing site hoarding will be replaced with a rolled steel protective pedestrian walkway, and the access platforms will be removed to make way for the basement construction. Once the basement has been constructed and the ground floor slab completed, the site welfare offices will be relocated down to the B3 level, and the existing block removed. The new ground floor slab plays an important role in the construction of the building. It accommodates the site access and egress from both Leadenhall Street and Undershaft. It forms a working platform and a transportation hub for staff and supplies. It is here that the material and passenger hoists begin their journey to the workfront. And it provides a launch pad for the megaframe that is the iconic feature of the tower. Construction of the main superstructure commences with the erection of a strongbox in the center of the building. This T-shaped frame forms the backbone of the structure and, combined with the smart craneage strategy, underwrites the whole construction methodology. Rising above the center T-box is the north core. This section of the building contains the washrooms, risers and lifts, and being modular in construction, will be erected in advance of the main office steelwork to allow ample time for the fit-out, connection and installation of the lifts and washrooms. The first mega level is located at level 5. The construction of the megaframe from ground to 5 requires careful planning and execution. The vertical columns that form the east and west elevation will be installed from the ground floor by mobile crane and propped from the strongbox while the level 4 floor steel is erected. The columns in the strong T-box will be installed up to the megaframe level to allow the lightweight temporary works to be suspended from the main columns, which in turn will provide support and access to the nodes for the connection of the megaframe structure. Once the level 12 superstructure is erected, the progressive stage stressing of the superstructure flank diagonals to ensure the building alignment start straight and end straight begins. Langer recognizes that the northern elevation of the building is key to meeting the challenging program for building occupation. This is where the majority of trade interfaces occur and the high-speed lifts are located. The construction methodology is based around a modular system, prefabricated and delivered to site, ready for installation and connection. The tables will be erected 7 stories high, independent from the megaframe, and a gantry crane on rails fixed to the uppermost level. The braced level of the outriggers, which provides structural support to the lift shafts, will be installed by tower crane and mechanical access platform. This braced level forms the support for a 3-story temporary working platform, which will be used to install the remaining outriggers and lift steelwork in each shaft. Once the structural steelwork has been completed, a monorail and hinged working platform or crash deck will be installed to begin the installation of the cladding panels for the lift cores. This platform has 3 main functions. Firstly, it provides a safety net for the workers and materials from above. Secondly, it provides a working platform for the hoists that guide the working cage within the lift shaft below. And thirdly, it supports the cladding monorail used to transport the cladding panels into position prior to securing to the slender lift steelwork. While the cladding panels are being installed, the modular tables and steelwork for the lift shafts continues above. Each section of the cladding panels are individually maneuvered into position from the monorail prior to being simultaneously fixed to the lift steelwork hangers. The installation of the cladding in a safe and secure manner has been carefully engineered by the Laing O'Rourke team. The main office tower features a distinctive megaframe with an outer and inner glazed skin, separated by a ventilated access walkway. A safe working area 5 meters from the edge of the floor plate has been designated for the cladding installation. Working from the mega level, the cladding hanger brackets will be installed to the underside of the mega beam and the floor levels. After the brackets are surveyed and checked for alignment, a mini crane will lower the hangers into position and, assisted by workers in mechanical platforms, secure to the structure. This process is repeated until all the hangers in a zone are completed. Once located, the walkways are then fixed from a mechanical access platform. Each external cladding panel will be delivered to the mega-level floor by the material hoists and guided carefully down the outside of the building into position. Working from the safety of a mechanical access platform, the panels will be secured in location. After the outer skin has been installed, the double-glazed panels that form the inner skin will be fixed, one at a time, using a manipulator completing the external envelope of the building. The installation of large-scale modular plant at levels 47 and 48 is integrated within the structural steelwork assembly, while the cooling towers and plenum boxes will be lowered and maneuvered into position prior to level 51 being fully enclosed. Accelerating the installation of the facade supports early mains power on and subsequent critical commissioning. Laing O'Rourke has built some of London's landmark buildings, such as Canary Wharf, One Hyde Park, Cannon Place, and are currently engaged in shaping London's Olympic Park. Laing O'Rourke has assembled a project team from across the group, supplemented by the world-leading high-rise engineer Skidmore, Owings and Merrill. Their approach will deliver the marketing suite at level 22 months ahead of tender expectations. The Leadenhall building, where the construction is the engineering is the architecture, and the architecture is what makes this iconic structure a unique tenant proposition for the City of London.